Hello, this is checkpoint 3.2. They want us to create a graph of the vector valued function, and they give the equation. So let's write it down. R of t is equal to t squared minus 1 in the I direction plus 2t minus 3 in the j direction. So this is our function, our vector valued function. And let's start off by making a table of values. Now they give us limits 0 to 3, so we'll just use some nice numbers for t between 0 and 3, and then hopefully that would be enough to be able to describe the graph. And then what we would have here is your r of t. Now we can look at this as a vector, but we can also look at it as a point, because remember, a vector is a line segment from the origin to the point that it's being described. All right, so let's put in some values. Like when t is equal to 0, we're going to have -1, and when t is equal to 0, we have -3. So -1 comma -3. When t is equal to 1, we're going to have 0, and 2 minus 3 is -1. When t is equal to 2, we're going to have 4 minus 1 is 3, and we're going to have 4 minus 3 is +1. And finally, when t is equal to 3, we will have 9. 9 minus 1 is 8, and 3 times 2 is 6. 6 minus 3 is 3. Okay. All right, let's draw our axis, our xy axis, and try to see where these points might be. -1 comma -3 is our first point. 0 comma -1 is our second point. 3 comma +1, 6, 7, 8, comma 1, 2, 3 is our third one. Okay, we can label these points: -1 comma -3, 0 comma -1, 3 comma 1, and 8 comma 3. And what I like to do sometimes is to be specific about what t values got us there. So we can label the t is equal to 0, 1 is equal to 2, t is equal to 3. Those are the t values that correspond to these particular points. And then let's draw the graph. So when we draw the graph, it looks like it's going to be doesn't look like it's a straight line. It looks like it's going to curve as a parabola. Yeah, so it looks like it's going to be a piece of parabola, and that's it. If we want to get specific about the fact that these are vectors, we can think about these points as vectors coming from the origin. And now imagine these vectors drawing out these points to get to those points on the graph, and it actually will draw out the curve. And there's a nice animation that we can find in CalcPlot 3D that allows us to visualize a vector, drawing out the curve, and that's why they're called vector valued functions. Okay, I hope that helps.